Engine start and liftoff.
Load relief kick rate is in. Vehicle's responding. Recovery.
The Mars Reconnaissance Orbiter travels over 306 million miles to get from Earth all the way to Mars. Now, this is kind of similar to archery. Imagine that you're on a range, you have your bow and your arrow. It's a pretty difficult sport to master. Several things you got to take into account. One, force with which you try to shoot the arrow. Second is the angle which you use, and then the distance away from the target. So in this, you have a number of factors that you have to bring together in a very nice and skillful way in order to get to the target exactly how you want to get it. And this is very similar to navigating a spacecraft. Basically, you have a target, which is Mars in this case. The bow is this 350-ton rocket that's going to propel our arrow, which in our case is just under 2.5 tons of the spacecraft. And the distance is 306 million miles, and we have to hit a target that's 60 miles wide in a planet that's not Earth at all. It's on the other side of the sun. So what does that mean? Well, that would be in essence trying to hit a target with an arrow from, say, here in Los Angeles all the way to Des Moines, Iowa. It seems like an impossible shot to make. So we're faced with that as navigators when we send something from here to another planet. But to make things a little bit more fair, we're given 4 chances to change the flight path of the spacecraft, the flight path of our arrow. So imagine that you shoot this arrow, and later you have the opportunity to stop, compare where it's going to where you want it to go, and give it a little nudge to make sure that it's on course. So essentially that's what we're doing with the spacecraft. During the flight path of the spacecraft from Earth to Mars, there are brief moments when we can give the spacecraft a little nudge using the thrusters. It's not totally cheating. It is a little bit because we track the spacecraft, we take measurements, and make sure that we go to the place where we want it to go. And these nudges are called trajectory correction maneuvers, and there are 4 of them designed for MRO. So imagine with the arrow, right as we're getting to the target, we have this last chance to stop, take a look, to give it a little nudge, and then it's straight on in till the end. So the analogy with the arrow was a pretty decent analogy, but in reality it's a little bit more complicated than that. Because we don't have an archer standing still and a target standing still, our target actually is moving around the sun, and so is the Earth. So we have that built-in complexity of the motion of Mars and the motion of the Earth. So it's pretty tough. It's not an easy task whatsoever, and any given mission is a challenge to all the navigators to be able to make all the precise calculations. And if we hit the target, right place, right time, and the spacecraft slows down the way we want it to, we'll get captured in about a 35-hour orbit around Mars. That'll be a big load off our backs. So until we see that the spacecraft made it there safely, we have a lot to do.